Hi, folks. Let's talk a little bit about the next very important scientist, and that is Sir Isaac Newton. Sir Isaac Newton was born the same year that Galileo Galilei died. And people who believe in such things usually go, ooh, when that happens. Um, he was the next generation, a whole generation younger, smarter, and much more informed than Galileo. One of my favorite quotes of Newton's, he said, if he stood on the shoulders of giants, that is why he could see further than other people. And he was referring to the works of Galileo and Kepler and Copernicus and all of the wonderful scientists that came before him. Newton was English, and he was one of the greatest physicists of all times. I also teach physics, and I can wax eloquently about Newton, but we're going to keep going with the astronomy. Newton discovered three laws of motion, and this is the underpinnings and the core of the study of physics. The three laws of motion are: one, the law of inertia. An object in motion tends to remain in motion. If you roll a ball across a desk, it's going to keep rolling until it hits something. The law of unbalanced forces basically means that if you apply a force to a small mass, it's going to accelerate a lot. If you apply the same force to a large mass, it's not going to accelerate much at all. That's Newton's second law. And Newton's third law is the law of equal and opposite forces. And what that means is if you are rummaging around in the middle of the night looking for a cookie and you bang your toe on the corner of a table, you hit the table with the same force that the table hits you back. And that's why your toe ends up hurting, because you hit a large table and it doesn't care, it's a table. But that force that's exerted on your poor little toe, and you hop around the house going, ouch. Besides those three laws of motion, Newton discovered what is referred to as the reflecting telescope. Reflect meaning mirrors. We'll talk more about this later. But this is one of the two primary basic types of telescopes that exist. Hubble telescope in space is a Newtonian reflector. This is an important design in the history of astronomy. Newton discovered that white light is made of all the colors of the rainbow. Prior to Newton, people thought that colors were impurities. And Newton discovered, oh, that's not true. If you put white light into a prism, when it comes out of the prism, it is actually going to be spread into all of the things that make it up. And those are all of the colors of the rainbow. In order to explain gravity, and we'll talk a lot more about gravity in a while, Newton needed more math than it existed at that time. So he invented a new kind of math called calculus. Some of you will have taken calculus. Some of you will never take calculus. It's an advanced type of mathematics. And Newton just invented this new fancy kind of math in order to explain gravitation. Now, the most famous story of Sir Isaac Newton is he is sitting in an orchard on his family farm underneath an apple tree. And Newton is trying to ponder what holds the moon next to the earth. What is actually making that happen? And the apple falls out of the tree. Newton himself reproduced this story and wrote down this story. And he said, in that instant, when the apple fell, he came to a realization that the force of gravity that holds the moon next to the earth is the same force of gravity that makes the apple fall. Now, honestly, ladies and gentlemen, that's kind of a boring story. I mean, guy sitting in an orchard watching apples fall. Again, there's no excitement in that story. But that story has persisted for hundreds of years. Why is this important? Why is this a big deal? Well, it's a big deal for these two reasons. When Newton made that connection, it was the very first time in the history of mankind that anyone said There is one rule that governs both the heavens and the earth. Remember how we started this journey back when we started talking about history, and we said that Aristotle and his buddies thought there was the earth, and then there was the heavens, and the gods lived up in the heavens. And they separated the heavens from the earth as if they were totally different things. Newton, when he made that realization that gravity was the same for the moon and the same for the apple, in one fell swoop he said, same thing. The heavens are just a further away version of what's here on earth. And that was a huge switch in how people thought. The second thing that Newton explained by explaining this universal gravitation, he explained the concept of a force acting at a distance, what we refer to as a force field. If you kick a soccer ball, you directly push on that ball and it rolls across the field. But if you could sort of just exert some sort of a force field on it, you could make the ball roll across the field without actually touching it. That's the concept of a force field. It, in its day, many hundreds of years ago, was considered almost magic, but he said that is the only way that all of this works, is that two things a long way away from each other can actually exert a force one on the other. So when we come back next time, we're going to explore more in depth this whole concept of gravity, because gravity rules astronomy.